let's walk through how we do the do now. So here, let's first identify what form we're looking at. I see two different x's as being multiplied. There's no addition, right? So this is in factored form, so we call this intercept form. So let's recall, that is the one where you have y equals some a value, and then x minus p, and x minus q. So right away, I can say easily my a is -1/2. I can't say what my p and q are yet, so I'm going to have to do some work. The first step is to take any factor with an x value and set it equal to 0. So I'm going to take my x minus 2, and I'm going to set it equal to 0. And I'm going to take my x plus 6. I'm going to set it equal to 0. And on rare occasion, with your a value, there's going to be an x there, and I would set that equal to 0. And then I would solve. How do I solve this? Well, if this says -2, I'm going to add 2 to both sides. I'm going to say plus 2, and I'm going to get x equals a positive 2. And this one, I'm going to say -6, and I get x equals a -6. The next thing I'm going to do is I'm going to plot those points. Now, I like to have fill shape, yeah. So I'm going to plot on my x-axis at 2. I'm going to plot on my x-axis at -6. Now, the next thing I need to find, is my axis of symmetry, or the beginning part of my vertex. Now, I prefer to do this graphically, but I'll show you both ways. Graphically speaking, what I'm going to do is I'm going to show you that the symmetry line is going to be in the middle. So the question is, what is in the middle between this -6 and +2? Well, graphically, I can count inward, or I could just take a guess. I'm going to put a line. I'm going to make it a dashed line that's a different color. It looks nice. And I'm going to say, I'm going to guess it's here. Well, if I guess it's here, then I'm going to make sure it's in the middle. So this line is 1, 2, 3 to the left, and 1, 2, 3, 4, 5 to the right. I'm wrong. It's not in the middle. So I'm going to erase it. I'm going to try it again. I'm going to put it here. And this is 1, 2, 3, 4 to the left, and 1, 2, 3, 4 to the right. Hey, I found the middle. Now, if you don't like that, there's another way. You could use the equation x equals p plus q divided by 2. That's like taking the average. If you took 2 tests, you want to find the average of your tests, wouldn't you add them together, divide by 2? So that would be, in this case, 2 plus -6 divided by 2, which would be -4/2, which would be my -2, and I got it. So I know that my axis of symmetry is x equals 2. That's how I would name that. Now, in order to get the rest of my vertex, I would plug it in. So we go back to my original. Remember, my original is y equals a -1/2 x minus 2, and then x plus 6. But I know what my x is. Now it's right here. My x is 2. So I'm going to take my x of 2, and I'm going to plug it in. I'm going to take my x of, that should be a -2. That's my mistake. It should be a -2, which means that's a -2. And this x turns to a -2. And I'm going to simplify. Now I'll tell you, -1/2. I'll tell you, so you're going to get 2 values in here, and they should be the same number in different signs. Should be a -4 and a +4. Now, do you remember when we were finding the axis of symmetry and we said, 4 to the left, you get that point, and 4 to the right, you get that point? Well, look at that. That's 4 to the left, that's 4 to the right, and I could say I am a happy person. Okay. Well, that doesn't tell me what my y is, but I'm one step away. I get y equals, well, negative 1/2 of 4 is positive 2 times 4 is 8. So I know that my vertex equals the negative 2x value that I plugged in, and then I got out an 8. And so I'm going to put a dot. It should be on my axis of symmetry at 8. And just to make sure, my a value is negative, which means it should flip. So it's an upside down parabola. Now, to find the other points. Now, this will get you the minimum shape, right? So you get the basic shape. But always what we're going to do is we're going to apply the 1a, 3a, 5a. So we recall that a equals negative 1/2. So what I'm going to do is just to make it a bit clearer, I'm also going to include the this shift, right? So normally that floor is on the x-axis. It shifted up 8. Now underneath that floor, I'm going to include my 1a and my 3a. But in this case, my a is negative 1/2. So 1 times, kind of running out of space here. 1 times negative 1/2 and 3 times negative 1/2. Let's scoot this over to get a little more space. Equals negative 1/2 on this case, and equals, I think it's negative 1.5. Just to keep it consistent, I'll say 0.5 because my a value was 1/2. So what this means is almost like a slope. I'm going to start at my first point, my beginning point, my vertex. I'm going to move over 1, down 1/2. Now I'm going to move barely at all down as I move left and right from the vertex 1. And then to find the next one, I'm going to move over 1 again and down 1.5. So down 1 brings me to the middle, and down 1/2 brings me there. And the symmetry point is there. And now I can draw as closely as possible a nice curve, which is easier said than done. Okay. That's most of it. Now I'm going to fill in whatever else it asked me to. So my y-intercept is wherever my curve hits the y-axis. I see it hits over here at 6. So I can just say 6 or 0,6. Then does it have a max or min? Well, this vertex is always going to be the vertex. Does it go all above or all below? Well, it goes all below, which means it tells me I have a max. So I'm going to cross out min. Alternatively, you can just circle max. And what is the value? Well, the highest it ever goes is 8. And I know that because I can't hit 9. Can't hit 10. Can't hit anything higher than 8. Okay. To fill this one out, what I'm going to do is first you have to identify what form we're looking at. Well, we're looking at, this is standard form because it's a whole bunch of pluses and minuses. No parentheses, no multiplying, just a bunch of this term plus this term plus this term. It's a classic trinomial. So we start by identifying what we know. I know I have a equals 3, b equals a positive 18, and c equals a positive 20. So the vertex is the tricky thing here. But we're going to recall, whenever we have a, b, and c, I'm going to look at my equation sheet, and I'm going to recall that I have an equation that says x equals the opposite of b over 2a. And so I'm going to start with the opposite of b. The opposite of b is negative 18. And we're going to write it as a fraction. So it's kind of weird to type, but I'll type it as a fraction. Over 2 times a. So 2 times 3. Order of operations, so you do the bottom first. 2 times 3 is 6. Negative 18 divided by 6 is negative 3. So I have a x equals negative 3. So that tells me that that is my axis of symmetry. I'm going to do my dashed line at negative 3. Oops. At negative 3. And oftentimes it's helpful to label that x equals negative 3. And that begins to tell me about my vertex. So I know that my vertex begins at negative 3 comma something. I don't know yet. In order to find y, we have to plug it in. So what we do is we say, well, y equals 3 times something raised to, whatever x is, plus 18 times something, whatever x is, plus 20. That's my original formula. So in these parentheses, I'm going to put the x value that I got. All right. We're going to order of operations this. So y equals, well, this term simplifies by first doing exponent. Negative 3 times negative 3 is 9. Times 3 is 27. Plus, and then 18 times negative 3 is going to be negative 54. And then plus 20 is just 20. Now, I know I'm right. I'm always looking for the happy face. I know I'm right when this double to get that, and they're different signs. So when I simplify this, I'll have to think about this kind of hard. 27, 54 make negative 27. Okay, so negative 7. So I know that my y value, my vertex, is negative 7. Okay. So what I'm going to do is I'm going to plot my first point, negative 3, negative 7. And I'm going to put a dashed line, dashed line at my new floor. Now, my new floor moved down to my vertex. All right. So it might be helpful at this time that I can fill out my transformations. We could do this after the graph. We usually do it after the graph, but I think right now it's helpful to see it. I know that I went from the original, I went left 3, I went down 7. That's easy to see because you could see my vertical line went left and my horizontal line went down. And then I'm going to say, in parentheses, I know that my a equals 3. So an a of 3 means I have a vertical stretch of 3. If it were negative, it would additionally be a flip, but it's a positive 3, so it's just a stretch. Now, this gets a little tricky. What I'm going to do now is I'm going to do my 1a, 3a, 5a, except I'm going up. Do you see why I go up? Because I have a positive a value. So actually, I have my 1a, 3a, 5a, and actually we don't really do 5a, excuse me, just 1a, 3a. And do you see how I put the 3a on top? Because it's going to be above the other one. That just helps me not mess up with like negatives, which are really easy to miss. So I know from the floor I'm going up 1a and then up another 3a. And since a is 3, you told me that earlier. Since a is 3, it is 1 times 3 equals 3. And then 3 times 3 equals 9. So I'm going to go right 1 up 3. I don't want to gloss over that. That's the big thing. From the vertex, I go right 1 and then do whatever the 1a tells me to do. The 1a tells me to go up 3. So I'm going to go right 1, up 3. 1, 2, 3. And then I'm going to do the symmetry point on the left. And then I'm going to go right 1 again from that point. Go right 1 and then up whatever the 3a tells me to do. Up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I think I hit 5 if I counted right. And then the symmetry point, 2 to the middle, and then 2 more to the side. And I'm going to do my best. And do my best to make a nice curve. It's an awful curve, but it gets the job done with arrows. Okay, now, this is tricky. We're going to expand on this more in class. But in order to move from one form or a graph to another form, particularly a vertex form, you want to know your transformations. So my transformations, first of all, the easy thing is the A. The A just repeats. The A is the same for all of them, so it's just 3. Okay. Now vertex form has the parentheses, always going to have an X. I'm going to put some space. It gets squared, and I'm going to put some space. Now the inside is my left or right. So since it moves left 3, I'm going to have a plus 3 inside. Okay? And then because it goes down 7, I'm going to say, after all of it, I'm going to say minus 7. That's vertex form. That's all it asks me to do. Now the last one is, what if I give it to you in this form? Now this form is recognizable because there's a single X. There's only one X. It's also super recognizable because it is like parentheses, like X in parentheses squared. So if you ever see an X in parentheses squared or you see a single X, this is the form you're looking at. So this is the A, H, and K. So A equals -4, H equals -5, and K equals +9. Depending on who's watching this, you may have different methods, and so you may say your H is a little different, but the important thing is when we get to the transformations, we're talking the same stuff. So let's talk about the transformations. The A equals -4 tells me to do 2 things. It tells me that it flips, and that is a reflection. It also tells me that it's a vertical stretch of 4. Not -4. The negative does the flip. The 4 does the stretch. Okay. The H of -5, or whatever you tell me your H is, you better be telling me that it goes right 5. And the K, being 9, tells me that I'm going up 9. So if you have all those filled out, we can start to graph. Now I'm going to start with my dashed red line. Oh, I didn't mean to change that color, sorry. But I'm going to move right 5, and so my vertical one goes right 5. My horizontal one goes up 9. And then my vertex occurs in the middle. All right, so let's see. Does it ask me to do anything with, axis of symmetry? So I graph my axis of symmetry. That's the vertical one. So remember, axis of symmetry needs to be an equation. X equals 5. Next up, I'm going to do my 1A, 3A. So my 1A, 3A. So you told me that my A is -4. Okay, so 1 times -4 and 3 times -4. Well, 1 times -4 is -4, and 3 times -4 is -12. Big numbers. Might be off the graph. We'll see. And remember, or notice, I'm putting my 1A, 3A close to my floor because I'm starting at my floor and I'm going down. I'm starting at my vertex and I'm moving down, in this case, 4, down 4. So it says go right 1, down 4. 1, 2, 3, 4. And reflection point. And then from here, I'm going down 12 now. Right 1, down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I counted right, I'm at -7. And reflection point. This is 2 away, so the next one is going to be 2 away as well. Okay. Do your best to draw a little curve. Be as clear as possible that you are aware it's a curve, not a V, even if you need to exaggerate that. And that is your quadratic parabola. Now let's start answering questions. My domain, as you know, is all real numbers. The range is a y question. It has to do with my y vertex. The vertex is up here at 9. And in this case, it's going down from there. It's all below the floor. Now, interval increase, decrease is a little tricky. Well, over here it is increasing, and over here it is decreasing, because as I move, I'm moving up until I hit my vertex, and I'm moving down the arrow. So it's decreasing to the right, and so my answer is going to be x is greater than whatever my axis of symmetry is, which is 5. My y-intercept, if I'm lucky enough, will appear on my graph, but I'm not lucky enough. But if I were to take a guess, I would guess -1,000,000. Why? Because this arrow is pointing down, and it's going to take a while to get, hit the y-axis. So it's going to be negative a big number. But that's not what you're looking for. You're looking for the actual answer. So it is what I get when I plug in 0. Y equals -4. Make that a little visible. -4. 0 minus 5 squared, and then plus 9. Order of operations, this says to parentheses first -5 square 25 times -4 -100 plus 9 -91. All right, I was a little off with my million, but it is negative a big number, -91, or you could say 0 negative. We would accept both. All right, and that's it. That's it. That's quite a statement. That was a lot of work. It's a long video, but this is a good summary. You're going to be doing at least one of these on one of each of these on your test.